It's a question I hear a lot. How much cooling do I need for, say, a 1,200 square foot house? Now, if you type that into Google, it's going to spit back some numbers of a tonnage unit you would typically need for a house that size. There's a very good reason why we don't size systems based on square footage. I'm going to show you why right now. So this is a little simulator I built that's going to show you why square footage doesn't mean a whole lot real quick. So let's design ourselves a 1,200 square foot house. Okay. So we're at 1,200 square feet right down here. And I'm going to turn on this thermal imaging view, and that is going to show us the actual air that we have to heat or cool down in the house. Now you can see we're at 1,200 square feet. And right here, we're just under 2 tons. Now that kind of lines up with the Google results we got earlier. But watch what happens when I raised the walls, let's say another 2 feet. So instead of 8 foot ceilings, we have 10 foot ceilings. You can see how the tonnage starts to go up. Now let's say we have vaulted ceilings, 15 feet high. So we went from 2 tons to almost close to 3 tons, or a little over 2.5 tons just with that, but we're still at 1,200 square feet. Now let's rotate around to the southern side of the house and let's increase the size of these windows. So we're going to make these nice big bay windows here. Nice and big. Move that one over a little bit. There we go. And you can see we're already at 3 tons. Now, if we look head on to the house and we start bringing that sun across the sky, you can see how the load changes as the sun comes in and shines in through those huge windows. We went from 3 tons to almost 3.5 tons just with all that heat coming in. That's heat your air conditioning system has to fight with just because of those big windows. And you can see how it changes the size of the tonnage we need and cooling to take care of stuff like that. Now, these are all the sorts of things that a manual J load calculation takes into consideration. And through all this, we never change the square footage, but our tonnage changed considerably. We can also, update our windows. We can go, if we have old single pane windows, you can see how the cooling needs to be a lot more. Whereas if we upgrade to modern low E, that brings us down. We can have these passive homes with insulation really, really tight, and that could drop us all the way down to 2 tons for that 1,200 square foot house. Even the age of the house itself can factor in. If we had a house that was, say, built in 1970, we still had all the original single pane windows, you could see how our tonnage really jumps up because of those old windows. We also have different insulation values based on building codes back then, so that changed a lot as well. Now you can play with this simulator on my website, jerseymikehvac.com. Totally free, don't have to sign up for anything. You just go play with it. It's not a manual J load calculator, so don't use this to try to size a system. It just shows you how many factors are in play when we're trying to size a system for a certain size of house. Square footage just doesn't do it. This explains why.